Hello everyone, it's Dr. Rafael Gutierrez again, and today I wanted to tell you guys about why a lot of times when we're in martial arts and we talk to someone who doesn't necessarily train in martial arts, uh, a lot of times we wonder what they are talking about, if they have a basic understanding. And to actually do that, I'm actually going to point to this little thing here. You may have seen this, it's called the standard distribution curve. And for the most part, like I said, the numbers change a little bit. I try to use whole numbers so you can see what I was talking about. If you actually take your average person, now I'm talking about an average person on any subject, they will actually fall between this line here and this line here. This is your average. Pretty much 70% of people will fall in any information they give you in this area. What I mean by that is this. Let's say you're a mechanic. Now, you will not be, if you're a mechanic, when it comes to cars, you will not be in this area. You'll probably be either in the 14 or even in this 1% way over here when it comes to knowledge. Your average person for mechanics would be probably someone like me. Actually, I probably am a little farther than exact average. So exact average would be right in the middle of this curve here. Most people will fall around there. It's called the standard deviation. But if you take someone like me who can change oil and spark plugs in his car, maybe replace a hose, I would probably be somewhere around this area here, average. Then you have people who pretty much, they maybe know how to turn on a car. They might be over here, and that's the extent of their knowledge. And so it goes on. So if you think about it, as if a mechanic is talking to someone and someone says, well, my car won't start, it's probably the battery. That's the answer someone here might say. A real mechanic will actually talk about all the different parts that it could be besides the battery. It's not just the battery. Think of all the parts and the electrical components that can end up leading to a car not starting. So what I'm saying is most people who actually know pretty much sit at a 15% of everyone else. Now, think about it. That's in every subject. So when you're dealing with martial artists, when you're dealing with martial arts, someone who actually watches MMA on TV and that's it, they are probably on the higher end of this average scale here. Someone who watches is really big into movies, let's say they're really big into Karate Kid, might be around here too. But if you notice, these are not people who know a lot. This is still your average person. It actually falls into the 70% of the population. There are a lot of people who will fall into this average area where the only thing they know is that kickboxing is a martial art, or judo is a martial art, or karate is a martial art. They would still be in this area here. Now, as you start getting into, if you think about it, if you have someone who has actually trained for a week in kickboxing, they're probably somewhere in this 14% area. And someone who's really big into Muay Thai, for instance, and has gone to Thailand to study and has read up on the history and knows who's who and is training, they'll probably be in this 1% here. Most people, again, will sit over here. I always like the quote George Carlin says about your average person. Take your average person, think of the dumb stuff they say, half the population doesn't know what they do. So this is actually a standard curve. And a lot of people now are trying to use science when they do research in martial arts, and it's a great thing. And some people I've actually seen who do a great job in collecting data and looking at it pretty much have said, well, I'm not a real scientist. And the truth is, I would say they are. I know that there's a gentleman, Seth Sensei, I think his YouTube channel is, and he does a great job at getting information. He doesn't try to tell you what it means, but what he does show you is, look, this is what we're seeing, and there's a lot of different things you could do with that data. I would love to actually work with them if anyone knows them, to actually show how to put the data together to come out with some really interesting things, because he does get some data. Now, one of the things is, depending on how much data you have, the better your information is. So for instance, a lot of times I actually tell people, if you're dealing with science or medical science, any peer-reviewed journal that deals with health, medicine, biology, embryology, virology, they actually tend to have really high intervals of what they actually do because their sample size is big. Think about this. This is actually your whole population. If you go and you grab 100 different people, well, you're going to have one curve. But depending on where you actually ask questions from 100 people, your curves may actually be in really weird areas. As you start getting bigger and bigger, you actually get more data and you can actually say, well, with more confidence what it is. Most of the research that if you go to PubMed and you go to peer-reviewed journals, rational peer-reviewed journals, as long as they're not editorials, and usually I tell people anything that's an editorial, don't even bother because they really don't have much to offer. You have about as much to offer as a YouTube channel. But the more data you have, the more information you have, the more confidence you can have. Just like this here. When you're dealing with data, there's different levels of confidence. For instance, if someone tells you it has if they have a high level of confidence, they're probably somewhere over here, probably about the 5% highest, and they would call that a 95% confidence rate. So if someone has a 95% confidence rate, it will really be somewhere around this area, and that's where they're so confident that they're far beyond what the average data collection would be. 95% would be a high confidence interval in statistics. Every so often you hear of something being a low percent, or a low confidence interval. Low percent, it would be, instead of being on this side here, it would be somewhere over here. Probably about, a low percent would be about 5%. So that's actually one thing when you're reading any report, you really want to pay attention to. Is it a high percent? Are they telling you 95% this is what is? Or is a 5% saying, hey, we have a 5% chance that this is what it is? You have articles that actually come out through people's labs, when they'll tell you, well, with the low confidence ratio, 5%. So they're saying 5% chance we're giving ourselves that this information is correct. That's what a low confidence, high confidence against 95. And I know it seems like I'm repeating myself. The reason is because I am. I actually want to drill that into it. Because recently there was a report that I actually have been hearing a lot of people talk about, where they actually mentioned that a government organization said that they had a low percent, a 5% chance of confidence. So they only have about 5% confidence that this report is right. But it's published, so it's news and people are talking about it. Now remember, when dealing with any subject, this is average. So if you take your average news channel, they're probably going to be somewhere around here. They don't necessarily understand how statistics and how research actually works. They're just reading to you what they are given to read, and they're not going to debate on it based on what confidence the person actually wrote it. 5% confidence is completely horrible. That's pretty much a joke. By the way, the government has actually labeled that a low confidence interval is questionable and using impossible information. So meaning they don't even trust the information they got. It would be like asking your Uncle Bob, well, what do you think of this? And so that's a really low confidence interval. When they tell you it's low, it means that it's questionable at best. Now, some of you may already figure out what I'm actually talking about. There was a thing that came out on, did COVID-19 come out of a lab? Now, we're dealing with a 5% chance that it may have, according to this report, but there's a lot of things they didn't really mention. One is, what type of lab was this? If it was a medical lab, that means that someone actually had the virus. They may have tried to do something with it to see what it would identify it, and maybe it attached to someone and went out. We don't know if it was a medical lab. They never said it. They just said a lab in China. Now, I will tell you, in general, I don't trust totalitarian governments. Anyone who's a totalitarian, anyone who tries to tell you that you shouldn't research your own thing using peer-reviewed, things with 95% confidence, you shouldn't listen to. A lot of totalitarian governments will actually try to hide information. I don't know Why? If you think of the old Soviet Union, you have Chernobyl, where they said, oh no, everything's fine. Well, the thing was blowing up. You also had the nuclear sub that actually was sinking, and oh no, everything's fine. It's supposed to do that. And later on, they realized, oh yeah, I guess we should have probably gotten help. So I don't really trust totalitarian governments, but when the US government comes out with a study and they say it has low probability, that's 5%. And we don't know what lab it came out of. It could have been a medical research lab. It could have just been some sort of lab that deals with getting viruses and trying to do a diagnostic lab. We don't know. The third type of lab is the one most people worry about, and it's a biological weapons lab. We don't know, again, what type of lab it is. All we know, it was a lab, and we know that it's a 5% chance that it came out of, that this report feels that they're correct. But let's go on with that. Let's actually go with that. And again, I'm going to tell you this. When it comes to microbiology, just like everything, your average person comes to about here. If you know anyone who's taken a microbiology class in a community college or a lower division microbiology class, I'm not talking about in a grad school, I'm talking about a lower division microbiology class, chances are they're somewhere in this range here. Now, if you ask anyone who's taken microbiology how much they know about the coronavirus, they will tell you not much. If you ask them if they can diagnose anything with probably not going to be there. So most of your people who mention COVID are probably below this area. To give you an idea, from here to here would be a C, D, and F. So the B or above people are the ones you actually should listen to. Now, why do I say COVID-19 coronavirus is a horrible virus for a biological weapon? Well, the first thing is the basics. Now, the basics tells you a lot. Anyone who takes general bio in a community college would know what a positive stranded single RNA virus would be. That's actually coronavirus does fall under those. And what it means is it actually has RNA which tends to mutate relatively rapidly compared to other stuff. And it's not really too stable. The reason that's not a good virus is there's a mutation rate. It means that if you make if you make this virus into a biological weapon, there's as much chance of it ended up killing you and your family as someone else, even if you think you have the treatment and cure for it. It can mutate enough relatively quickly to kill you. Not a good virus to use, unless you want to bring the apocalypse for some reason. Some idiots actually do, but we won't go into that. Now, the other reason this is actually not seen is it doesn't seem like a good one for a biological weapon is it's already known that coronavirus tends to jump from species relatively quick. Again, it has a relatively high mutation rate. Actually, to give you an idea, your body has billions of cells. And for the most part, this virus will mutate one time in every 100,000 cells. Remember, you don't have one cell, you have billions. And it goes from 1 to every 100,000 to 1 to every 1,000 cells. So this virus is horrible for a biological weapon because if you have a cure for this one, in a couple days, you have multiple strains that it may have actually mutated enough that you can't control it anymore, which means you're just killing off your population. Congratulations. Now, those I actually can say with a 95% confidence because, well, I've taught the microbiology before, I've taken microbiology before, and I actually do know what a positive single-stranded RNA virus is. Go figure, I taught the thing, right? And so that's actually one of the big things I actually want you to actually pay attention to is most people are over here. And remember what George Carlin said about your average person. Your average person is not that bright, and half the population isn't going to be as bright as that person. I hope you enjoyed this, and if you did, leave a comment. If there's any other subject you'd like me to mention, I will say I haven't made a lot of videos, mainly because I haven't thought of anything new I can present to you in either martial arts or in science. And recently when this came out, I thought this is a great topic which I can actually present to you. So if anything else comes out, please let me know, and I definitely will talk about it. Thank you and have a nice day.